Transformers and motors. Before we get started on transformers and motors, I want to talk a little bit about power generation and how our power is created. It's going to help you understand a little bit better how transformers work and how motors work. Now, it doesn't matter how our power is generated, whether it be wind turbines or through a dam that produces electricity or nuclear power. What they do, all of these turns a magnetic rotor inside of a generator, and we'll look at one here. So picture your wind generator turning this magnet inside the stator. Now when this magnet is turning inside the stator, it's creating a magnetic field that expands in one direction, then contracts, and then expands in another direction. As that magnetic field cuts through these wires, no matter which direction it cuts through, it's going to do what's called inducing a current in these coils of wire. And the stronger the magnetic field, the more current that is induced, and the more wires that are in that magnetic field, the more current is induced as well. So just remember, a magnetic field that cuts through a coil of wire will induce and cause current to flow. So transformers. Let's get on to transformers here. Now, remember I said it was when we generated power, it was done through induction, and you see that transformers have two inductance coils that are wrapped around a magnetic core, pretty similar to what you saw with the generator over here, where we have one coil wrapped around a magnetic core. With the transformer, we have two. So let's take a look at how that works. So the transformer we see here has a primary and a secondary coil. The primary coil is what's connected to the incoming power. So that generator that we looked at earlier, it is creating power by spinning that magnet inside the magnetic core and inducing the current to flow through that coil. And wherever it may be, it's sent through the transmission lines and wired right into the primary core of the transformer. I don't want you to worry about this equivalent resistance right now. So we have our rotor that's spinning inside of that magnetic coil, inducing current, which flows through the transmission wires, and it runs this current through these coils on the primary side. When you run current through a coil of wire, it creates a magnetic field. So it kind of undoes what we did over here at the generator. So we took a magnetic field, ran it through coils of wire, transmitted that induced electrical current, ran it through another coil of wire, and now we have that magnetic field over here. So what happens is, as this magnetic field expands and contracts on the iron core, it induces the magnetic field and induces current over here on the secondary coil. So this expanding and contracting magnetic field cuts through these wires back and forth and induces a voltage and current over on the secondary coil. So that is how a transformer works, so we create, once again, we take mechanical energy, then we rotate a magnet through coils of wire that creates electrical current, then we run electrical current through coils of wire that creates magnetism that cuts through other coils of wire that create more current. Now the reason that we have a transformer, though, is we can't use 100 and don't want to use 120 volts as control voltage for our HVAC equipment, and it's much easier and takes much smaller power requirements and much less expensive controls if we can step it down to 24 volts. So the very nice thing about transformers is that we can take 120 volts over on the primary coil over here, and if we have for if we have one coil of wire on the secondary side for every 5 coils of wire on the primary side, it's going to divide the voltage by 5, and that's called a step down transformer. And if we have a transformer and it's has a 10 to 1 turn, it's going to reduce the voltage by 10. So it would be a 12 volt transformer. If it was a 2 to 1 turn, it would be a 60 volt transformer. But we in HVAC we use the 5 to 1 turn on the primary and secondary coil in a 120 volt system. So what would it be if we had a 240 volt primary coil? To get it down to 24 volts, we would need to use a 10 to 1 turn transformer, and that's how that works. Now transformers can only handle so much voltage and amperage, and transformers are rated in VA, called VA or volt amp rating. And the way you get volt amp rating is you multiply the voltage times the amperage, and these are all rated on the transformer. So you can see usually it's 40 VA transformer that you see, and the way that you make sure that you don't overload your transformer is most of the control devices in the HVAC system will have a VA rating, and a 40 VA transformer can only handle 40 VA worth of load before it burns out, and that's the equivalent of 1.6 amps, and that is if you divide 24 into 40. That's how you get that. Okay, so that is it for transformers. Please review in your book a little bit about the VA ratings, a little bit more about that, and we will move on to induction motors, the basic induction motor, and then we'll break down each individual one piece by piece so you get a thorough understanding of those.